Now, with example number 4, they say a learner should determine what is going to be dy and dx. Okay? Now, they gave us two equations. They say if y is equal to. Now, let's look at equation this one. We can call it equation number 1. If we look at equation number 1, it has y also has x. Okay? Now, meaning which it satisfies the condition number 1 because I do have y as the subject. Can you see that? Okay? And then I'm differentiating in terms of what? Of x. So I can use equation number 1. I can't use equation number 2. Why equation number 2 I can't use it? It's because there's a z and then there's a 1. There's a y. Hey, what? So if I were to differentiate this one, remember, first I need to remove the bracket. Okay? So if I were to remove the bracket for number 1, I am going to have something like this. Y is going to be equaling to 6x, okay? Minus 2x squared, like this. And then what is going to be dy all over dx then? Dy all over dx, it says there's a 1 here, which is going to be equal to 1 multiplied by 6x 1 minus 1. Yes. And then it says which we have plus 2 multiplied by minus 2x squared minus 1. Yes. We're still fine with that one. Right? Yes. And then what are we going to get for that one? Yes. We get 6. Okay? This one is to the power of 0, so we'll leave it as 6. Okay? So we're going to have 6 multiplied by 1. And then we have 2 multiplied by minus 2, you get plus 4x. Okay, this is our final answer. It's the deal. Okay, now let's go to number 2. What do they want for number 2? They say determine dz all over dy. I've been specific here. Yeah. What should be the subject? Yeah. We're differentiating in terms of what? 1. So our equation is fine because that is the fact subject. Okay? Yes. So now we're differentiating in terms of what? Yes. So let me write this one here, number 2. So what are you going to have? You have z, which is going to be y all over 2. Okay? Now dz all over dy is going to be given as, there's an exponent 1 here. Okay? Yes. It's on the numerator. If it was on the denominator, we're going to take it up. So because it's on the denominator, it's fine. So we're going to have 1 multiplied by y, 1 minus 1, all over 1, all over 2. And then 1 all over minus 1 is going to give us what? 0, which is going to be 1 all over 2. Still clear? Now let's go to the last one. Number 3, they say determine what is going to be dz all over dx. Now let's look at that equation here. We have 2 equations. Okay? Is there any equation that has both x and z? Do we have an equation like that? No. It's not there. Now, since we don't have that one, what are we going to do then? We are going to combine these 2 equations. Remember, on this one, there is y. Okay? This one, it has y. Can you see that? Okay? This one also has what? Y. So I am going to say, let's remove this y because we don't need it for this one. We need z and what? And x. So let's make y the subject of this one. Can we do that? Okay, let's try it. We are going to make y the subject. Oh, we can do this. We can then say we have something. Actually, we're trying to make, we can call this one equation number 1. Ne? And then we call this one equation number what? Number 2. And then we sub, this is number 3. We sub 1 into 2. Now, if you were to sub 1 into 2, what are you going to have? You are going to have something like this. You are going to have, instead of, we have z, which is going to be equal to, instead of y, we're going to put a simplified version of it. This one, you see this one? We have 6x, okay? Minus 2x squared. All over what? All over 2. Now, we can then separate this one. Agree? Both of them, they're all over 2. It's like saying you can have 6 all over 2x minus 2 all over 2x squared. Does that make sense? Okay. So we are going to have something like this then. This one is going to give us 3x. Okay? This one divided by this one. Huh? And we have 6 divided by 2. Yes. We have 3x. Is this one? It's like we're saying this one can go with this one. I can remember. They say if the denominators are the same, we simply add the numerators. It comes from here. if I have 1 all over 2 plus, and then I have x all over 2, yeah? I can then say I have 2 all over, which is going to be 1 plus x. I can, if this is true, going there is true, it means I can take this thing backwards. So I have 2 here, and then I have 6x minus 2x squared. So what did I do? I then said this thing here can be all over 2, and then this one here can be all over what? All over 2. And then here we're going to have minus x squared. Okay? Then we can differentiate. We're going to have dz all over dx. Then we're going to have 1 multiplied by 3, which is going to give us what? 3. We have 2 multiplied by minus 1, which is going to give us minus 2 x, because we subtract 1. Okay? And then that is going to be our final answer. Then we go to activity number 4, which is the last activity of the day.
Yes.